assuming that you allow that one to stay. Then after the regression, you need to also check the variance inflation factor. And if there's a multicollinearity, we can also see from the variance inflation factor. And if the variance inflation factor is above 10, it is a cause for concern. We should be concerned for that. So, and if it is less than 10, it means that there's no multicollinearity. And don't forget that the variance inflation factor moves with what we call tolerance. And for the two, tolerance is equal to 1 over variance inflation factor. So we expect our variance inflation factor to be less than 10. So if the variance inflation factor is less than 10, it means that there's no multicollinearity, and that is what we want, no multicollinearity. That is right. If we have variance inflation factor greater than 10, then it means that there's a problem with our model. If you're also using tolerance as an indicator, then we want our tolerance values. These values will be computed alongside your regression when you are using any of the statistical software. So if the tolerance is very small, if tolerance is less than 0.1, it's bad. But if tolerance is greater than 0.1, then it's good. So this one indicates that no multicollinearity. Okay. So when you run a regression, you need to check on those things before you interpret the results. So you need to check on the multicollinearity. You need to check on the check whether there's a multicollinearity. You need to check whether there's a linear association, sample size is large, normality, random sampling, and then also look at the instrument for the dependent variable. They are key, and you need to look at them before you interpret your results. Now, when you get the results, you need to now also look at it, diagnose the results. In fact, when you have done the regression, for example, if your y is equal to a plus b1 x1 plus b2 x2 plus e, when you run this regression, you need to check for diagnose your y. You need to diagnose your independent variables, and then possibly you check your error term. Okay, you need to check for the error term. Now the dependent variable, you diagnose it by using the model summary. That is the coefficient of determination, your R square or adjusted R square, to see the level of to see the goodness of it, whether the model is being the independent variables is explaining greater proportion of the dependent variable. The independent variables are explaining greater proportion of that. Then you also need to check this and make sure that these ones are not equal to 0. In fact, if you have a model and all the coefficients of the independent variables are all equal to 0, then it means that that model is not good. And you can also get that one by checking the joint significance between this and that. Though this one, there could be a relationship between this and that, and the relationship between this and that, but does not mean that when you put the two together, it will have a relationship with y. Because, for example, let me use this analogy. We know palm nut soup is delicious, milk is good, butter is nutritious, sugar is good. For kids, actually, I mean, it's delicious or sweet. but you cannot put all of them together. You cannot do your palm nut soup and then when you finish, you put some butter in it because you want to prepare a nutritious food. So you put butter in it, you put some small sugar in the soup. It will end up turning poisonous because they cannot be added. But if you take them individually, they are good. Palm nut soup, good. Then you take your butter alone, is very good. You take maybe sugar alone, it's okay. But when you combine them, it could turn a poison. So those are some of the issues you're talking about. So that doesn't mean that because this one explains this one explains this, means that when you put the two together, it will be a good model, or the together will explain. So that is the one aspect that you need to also look at. So you need to check for what we call joint significance. Joint significance. So the joint significance are tested using the F statistics of ANOVA, and therefore that F statistics, we check H naught is equal to B1 is equal to B2 and is equal to 0. So it means that B1 is equal to B2 and is equal to 0 as alternative, and the alternative is that B1 is not equal to B2 and is not equal to 0. So it means that at least one of the variable is not equal to 0. Okay, so if all the coefficients are equal to 0, it means that the model is not good. And you can do this one by checking using ANOVA. Okay, and you use F statistics. Okay, so this is that's what you have to check. Then when you finish, you can then also check the null hypothesis on each of them one by one. You can check on this one, and that is where you have to test for significance. So you are checking whether the coefficient, so for example, if it is y equals a plus b1 x1 plus b2 x2 plus e, then we need to check one by one the null hypothesis that b1 is equal to 0, and the alternative is that b1 is not equal to 0. So this is for x1. Then you also check for b2, which is under hypothesis. We also check h naught is equal to b2 is equal to 0. Alternative is that b2 is not equal to 0. So you test for those things. And the hypothesis, you use t statistics, and the t statistics here is that the predicted, the coefficient b divided by the standard error of the b, okay, will give you the t statistics, and we will illustrate it when we do a demonstration. And when we do that, we, as usual, we expect our p-value. If your p-value is less than your significance level, then you can reject the null hypothesis that b1 is not equal to 0. So once this one is not rejected, it means that S is not explaining that, because if this is 0, 0 here will eliminate everything here. But if it's not equal to 0, it means that S1 will stay. But if it is equal to 0, it means that S1 has nothing to do in the equation. So that is what we do. So typically when we take alpha level of 0.5, we can work on that. Now let's look at it. Let's demonstrate it. Let's do some demonstration of this issue. Now let's pick a data from here. So let me pick this data. We are familiar with it. Okay. So let's assume that we want to do some statistics. We want to look at what influences life expectancy. So we are calling it LE. and we are assuming that life expectancy is affected by adult illiteracy. So B1 adult illiteracy, which I'm calling AI, plus B2, which is human development index, plus B3, which is level of intolerance for corruption. So I'm calling it CPI, plus B3, which is quality of life, QL, then plus E. So this is how the regression equation will look like. So we are now going to estimate these coefficients. Okay. So in that case, we will go to our data here. And then when you go to data, we go to analyze. We go to regression. We are going to linear regression. Now when you get that, you see when you open, you have dependent variable and we have independent variable. If you check our this thing here, we have our life expectancy to be the dependent variable, and the independent variables are adult illiteracy, AI, human development index, consumer price corruption perception index, intolerance for corruption, and then quality of life. And this becomes your error term. So whenever you run regression, there should be an error term. Okay. Okay. So let's go back to our distance. So we have it here. So the dependent variable is life expectancy. So we are assuming that the life expectancy in a certain country or in countries across the globe depends on the adult illiteracy, depends on human development index, depends on corruption, and depends on the quality of life. Okay, so the first thing that we need to do is that though we have dependent variable here, we have independent variable here, but the first thing we need to do is to look at whether there is it meets the assumptions that we are looking at. So the first, we need to see whether life expectancy is measured on a continuous variable. And life expectancy globally is measured about the average age that people die within a country. So that one is a continuous, because about age is a continuous variable. Then we look at whether the data is randomly selected. Here we can only assume because we were not there when data was being collected, but we are assuming that it was randomly selected. Then we want to see whether the sample size is large. Now, the sample size we are using is about 180. Then we have how many independent variables? What are the independent variables? Yes. You're right. Okay. The independent variables are adult illiteracy, human development index, quality of life. So the three are the independent variables. Okay. Then we want to, the dependent variable is that, so once that is 3, when you divide the total sample size, which is 180 by 3, it should be greater than 15. So 180 by 3 is automatically going to be greater than what? 15. So it means that sample size is okay. Then the next issue is to look at whether there is a multicollinearity, or we want to see whether there is a linear relationship between the independent variables and the dependent variable. So what we do is that we need to run a correlation matrix. So we go to here, analyze, go to correlate, and pick by variate. And because we are looking at life expectancy as a dependent variable, we pick that one first. Then we have adult illiteracy, level of intolerance for corruption. We have human development index, and then you have quality of life. I think this one forms the equation. Let me see. Oh, sorry, this one should be 3. And this should be 4. Very good. Okay. So these are the variables. So we then click OK. Now when you click OK, we want to see whether there is a linear association between the dependent variable and the independent variables, and there should be significant correlation. So we realize that between life expectancy, adult illiteracy, and life expectancy, because the independent variables are 1, 2, 3, 4. 1, 2, 3, 4. Adult illiteracy, level of intolerance for corruption, human development index, and quality of life. Dependent variable is life expectancy. So we want to see between adult illiteracy and life expectancy. Okay. Then we want to also see between level of intolerance corruption and adult illiteracy. And in this case, you realize that each of them, between adult illiteracy and life expectancy, there's a very strong negative correlation. The same thing applies to level of intolerance for corruption. The same thing applies to human development index. And then life expectancy is also large. Once you do that, it means that there is a linear association between the independent variables and the dependent variables. That one has been established. Then we want to then look at whether there could be a possibility of multi-collinearity. In that case, you need to look at correlation among the independent variables. So we are coming to look at among these independent variables. So we are looking at adult illiteracy, level of intolerance for corruption, human development index, and quality of life. So you are looking to look at between this and that, between adult illiteracy and level of intolerance for corruption, between adult illiteracy and human development index, between adult illiteracy and quality of life. So let's see. So between adult illiteracy and level of intolerance for corruption is here, because we have adult illiteracy and the level of intolerance for adult illiteracy and then level of intolerance for corruption. There is correlation, but that correlation is not up to the 0.9 cutoff, because we say we want 0.9. Now between adult illiteracy and human development index, we are having negative 0.9. So it's an indication that there could be a multi-collinearity factor, because it's very high. We don't expect the correlation to go above 0.9. So here we have 0.9. So we need to be concerned about this. Okay. Then between adult illiteracy and quality of life, we have negative 0.764. That one too is okay. Then we come to level of intolerance for corruption and human development index. That is about 0.8. So that one is okay. Then between level of intolerance for corruption and quality of life is about 0.653. That one too is okay. Then we come to human development index and quality of life. That one is okay. So in all cases, realize that it's only between life expectancy, between adult illiteracy and human development index, which could pose a problem for us in our regression model, because the regression model, we are saying that there shouldn't be any multi-collinearity. Okay, so once that we have seen that, so in a normal case, we should drop one of the variables. We should drop either adult illiteracy or human development index. But let's assume that we want to test, so we are not going to drop them. So let's see what happens next. So let's delete this one out. Now let's see, we then move on to a regression, because now we have satisfied the conditions needed to run the regression. So we go to analyze, we come to regression, go to linear, take that one. Our dependent variable is life expectancy. So we just push life expectancy. Then our independent variables are adult illiteracy, push them here. Then we have level of intolerance for corruption is here.